Hello, everyone. My name is Kaymie Shiozawa, and my colleague Rika and I are from the Newman Laboratory for Biomechanics and Rehabilitation. We have been working on estimating human joint stiffness to optimize novel balance aid designs, and we are very excited to be here today. In the United States and all over the world, an aging population where the elderly outnumber young people will cause many societal and medical problems, one of which is balance disorder. To remedy balance impairments, walk aids such as canes are often prescribed. A common belief is that we use canes to improve balance ability by increasing our base of support. But the cane itself is an unstable tool. It won't stand on its own. So the user has an additional job of having to stabilize the cane. To stabilize a hand tool like a cane, previous studies have shown that the stiffness of the limb, the upper limb in this case, limits how much force you can exert, or in other words, how much you can depend on the cane. When we looked at literature, we realized that there are many studies looking at the forces on the upper body when using canes, but not the stiffness during cane usage. So the goal of this project is to investigate necessary upper limb stiffness to stabilize a cane. To accomplish this goal, we are developing simple mathematical models and comparing it with human subject data. We hope that our study can inform proper use of current walk aids, as well as inspire the development of novel rehabilitative devices.
As a first step, we collected human data. We had 2 young female subjects participate in our preliminary study. We varied the cane length and the cane placement distance from the ankle, and we measured axial force on the cane, ankle torque, and body lean angle. Here's the raw data that shows how the distance of the cane from the body and the cane length affects the maximum lean angle of the subject. We wanted to see if our model can explain the trends that we observe, such as the increased lean angle as the cane distance increases while the cane length decreases. Here is the current iteration of our model, with which we are trying to explain the data. It consists of shoulder, elbow, hand, and ankle stiffness parameters to conduct stability analysis. We consulted literature to determine physiologically plausible values of joint stiffnesses to use in our model. And with this, we computed lean angle for different cane parameters. The results are plotted here, along with the experimental data. The model seems to explain the overall trends well, suggesting that joint stiffnesses are important in determining the stability limits when using a cane for balance support. We are currently working on refining our model to better fit the experimental data, and we hope to use our model to better understand how canes and other devices can provide people with physical support while standing. Thank you. Here is some information about our funding sources, as well as information about Kaymie and I. And we'll be at MechE in person, so feel free to come chat with us. Thank you.